Okay, good morning students. So in the previous video we talked about pressure and force and how they are related to each other. We talked about different types of forces. We talked about pressure. Pressure is force upon area. We also saw that if the area increases, then the pressure on the surface decreases, and if the area decreases, that is the area of contact, then the pressure increases. That is why it was easier to push a pointed nail than a blunt nail, or it is easier to cut the vegetables with sharper knife than the blunt knife, because the blunt knife has more area on its edge, so the area of contact with the vegetable is more, and therefore vegetables feel less pressure, and that is why it is difficult to cut. In the same way, the syringes of the doctors are quite pointed and very thin, so that it is easier to inject inside the skin without more force, because if the pressure is less, then obviously doctor has to apply more force. But in the same way, we are also going to study forward into another topic. That was about the pressure of an object on another object. We were talking about pressure of an object on the surface of another object. But what about liquids? So now we are going to talk about how liquids exert pressure. Liquid pressure. So obviously liquids also exert pressure on the surfaces, but how? So they exert pressure in the containers in which they are kept. Okay, so suppose we have a container over here like this, and we have kept water inside it. Now how does it exert pressure? In order to understand how the liquids exerts pressure, we are going to do simple experiments in order to understand that. Okay, so first simple experiment that we are going to understand is, take a glass tube that is transparent and it is hollow on both the ends. That means it does not have a bottom, so if you pour water inside, it will flush out to the other, or you can say it's a glass pipe or a tube. So a small tube you have taken which is of glass, and then what you have to do is you have to attach a rubber balloon on one of its end. So on this end we have attached a rubber balloon. Okay, so we have attached a rubber balloon. Fix this rubber balloon tightly with the help of rubber band. So you take a rubber band and attach it on this rubber balloon so that it gets tightly fixed on this place on the tube. Now simply add water in it. After adding water, let's say to a certain limit over here, you will see that the size of the rubber balloon increases. That means the rubber balloon is getting bulged up. So it is getting bigger and bigger because the water inside it is filling up the balloon. What does this experiment suggest? Why is the rubber balloon getting filled up, and what is happening to the tube, and what is the water doing? This simply applies to the argument that when we pour water inside this glass tube, what happens is that at the bottom of this tube, that is the container tube, that is our container, this water is applying pressure on this area of the tube. It is applying pressure on this area of the tube. However, now it is having no tube, it is having no bottom. So what is the bottom for this water? The bottom is actually the rubber balloon. So it is applying pressure on the rubber balloon instead of the container, because this container is hollow. There is no bottom to the container. And so what is happening is this rubber balloon is actually applying pressure to the bottom, and in this case the bottom is the rubber balloon. So the rubber balloon is getting the pressure of the liquid, that is water, and because of which its size increases. because it is getting filled up with water and water is applying pressure on it. That is why. Now in this simple experiment we will add more water. Now the water level has been increased. Obviously the level of the water balloon or the size of the water balloon will also increase. The size of the water balloon will also increase. What does this indicate? It indicates that if more liquid is inside the container, then more pressure at the bottom. So at first the water was up till this height, and now the water is up till this another height h dash. So we have increased the height of the liquid, we have increased the quantity of the liquid. So what happens is that when you increase the level of the liquid, then the pressure at the bottom of the container also increases. If we increase the height or the quantity of the liquid, then the pressure on the bottom of the container also increases. Okay, forget about the tube. If we have a simple glass of water, if we have a simple glass of water, that means if we have water inside this glass, then we have pressure at the bottom of the glass. Although we do not feel it, we experience it with the help of this rubber balloon. But from now onwards you have to understand that if we have a simple container like even this small glass, then also the water inside the glass is applying pressure at the bottom of the glass. Now if there is more water, then obviously the pressure on the glass, the pressure on the bottom of the glass is also more. So more water means more pressure. So if we apply more liquid, then more pressure. Obviously it changes for the type of liquid that you are using. If we have different types of liquid, then different types of pressure is applied. For example, oil is heavier than water, so oil is going to apply more pressure on it. If we are having kerosene, then kerosene is going to apply another type of pressure. It is, let's say, somewhat lighter than water, so then it is going to apply less pressure than water. But different types of liquids apply different pressure. Okay, I hope it is clear to all. Let's move on to another activity related to liquid pressure. We take a small water bottle, or you can take a small plastic bottle. We take a small plastic bottle and we make 3 holes in it. 1, 2 and 3. We make 3 holes in the bottle. Now we cover it with a simple tape so that the holes are blocked right now. When we apply the tape, after that we pour water inside it. So we fill this bottle completely up till this level with water. Now we remove the tape from starting from the bottom over here slowly, and you will see that as soon as we remove the tape, the water will start coming out from all the 3 holes. But you will see that at this point, where the hole is at the bottommost portion of the bottle, from that point the water going will be at the maximum distance. Then from the bottom water will be flowing like this, and from the top water will be falling like this. Why is this? Because the pressure at the bottom area is maximum, and because of this the water coming out from this hole is at the maximum speed, and therefore it will travel the maximum distance. When we are applying water, when we are filling this bottle with water, and what happens is that we are applying more pressure at the bottom. So that is why when we open the tape, the water starts coming out from all the 3 holes, but the water will be going the maximum distance from the bottommost point because at that point, at that hole, the pressure of the water is maximum, and that is why that water will be making the most distance from the bottle. And as we move higher and higher, the pressure gradually decreases. So inside a container, as the height increases, the pressure at the top decreases, or you can say as the depth increases, as the depth increases, then the pressure at the bottom increases. I repeat once again, we saw in this activity that first one, we take a hollow tube that is open on both the ends, we attach a rubber balloon on it, and from this we come to know that when we fill it up with water, the rubber balloon starts to bulge up. It starts to get bigger in size because the water is applying pressure on the rubber balloon and it gets filled up, which proves that the water or the liquid applies pressure at the bottoms of the container. And when we filled more water, then the balloon got bigger and bigger, or larger and larger, and because of which we come to conclusion that when the water in the container increases, then the pressure at the bottom also increases. When the level of the water or the level of the liquid in the container increases, then the pressure at the bottom also increases. We also saw another activity in which we have taken a small plastic bottle. And we made 3 holes in it. In all the 3 holes, we added water, and when we saw the water coming out from all the 3 holes, we found out that the water coming out from the bottommost hole is going the maximum distance, and as we move higher and higher, the distance covered by the flowing water decreases. It is because at the bottom, the water pressure is maximum, or the liquid pressure is maximum, and that is why water coming out from the bottommost hole is covering the maximum distance because it is having the most speed. And that is why as we move higher, the speed of the water decreases because the pressure also decreases. I hope it is clear to you.